Right. Hydrocarbons. Right on. You write separately. The topic will continue tomorrow class, but today's class we shall try to finish hydrocarbons, at least alkene. Right on. Hydrocarbons. Right. So listen. So what are hydrocarbons? What are hydrocarbons? Classification of hydrocarbons, and we have in our syllabus alkane, alkene, alkyne, and benzene and its compounds. These are the hydrocarbon. Their preparation properties we have in our syllabus. Okay. Tell me. So what are the hydrocarbon? Hydro means hydrogen. Carbon is carbon. Right. Asadane. The organic compound which contain carbon and hydrogen, right? So the organic compounds which contain carbon and hydrogen called, yes boys, the organic compounds which contain carbon and hydrogen called hydrocarbons, right? So hydrocarbons are generally classified into how many types? Two types, no? What are the two types? Saturated. Okay. Saturated hydrocarbons. Second one is unsaturated hydrocarbons. Okay. Tell me. So what are the saturated hydrocarbons? The hydrocarbons which contain carbon-carbon single bond, right? The hydrocarbons which contain carbon-carbon single bond called saturated hydrocarbons, right? So what are the example for saturated? Can you tell me what is the general formula of this saturated? CN H2N plus 2. Then examples are what? Alkene. Yes or no? So therefore saturated hydrocarbons contain carbon-carbon single bond, and their general formula is CnH2n plus 2, and their example is alkene. Next is unsaturated hydrocarbon. Unsaturated hydrocarbons may contain carbon-carbon double bond or carbon-carbon triple bond. Yes or no? So they may contain double bond or triple bond, and what is the general formula? CnH2n or CnH2n minus 2. Then what are example? Alkene and alkynes are example for unsaturated hydrocarbons. Okay. Now today's class we shall study about alkanes. Alkane. What are alkane? Preparation properties. See here, in all hydrocarbons important is only preparation property, that is equations. Other thing we have studied. In alkane we will get isomerism, particularly conformation isomerism. That conformation isomerism we have studied. And in alkene we will get geometrical isomerism, that also we have studied. Okay. So only important thing is equation, that too particularly preparation property equations, right? That you need to remember it. Okay. So let us start. Alkanes. Alkene. Tell me, what are alkanes? Saturated hydrocarbons containing carbon-carbon single bond. Yes or no? So saturated hydrocarbons containing carbon-carbon single bond called alkanes. These are the saturated hydrocarbons containing carbon-carbon single bond. called alkanes. Next, do you know alkanes also called paraffins? Why they are called paraffins? They are also called paraffins. The meaning of paraffin is, para means it is a small or little. Affin is what? Affinity. It means alkanes having very small affinity towards chemical reactivity, chemical reactions. That means, so paraffins are, they are have small affinity towards the chemical reactions. So of course alkanes are the almost they are chemically inert organic compounds, therefore they are called paraffins. Therefore here alkanes are also called paraffins. Para means a little and affin means affinity. They have a little affinity towards chemical reactions. Next, what is the general formula for alkane? CnH3n plus 2, where n equal to what? Number of carbon atoms. Okay, so next is structure of alkane. Tell me. So this is also we have studied. To understand the structure, we need to understand first hybridization lone pair, right? So what is the hybridization of carbon in alkenes? Let us take example methane. It is the simplest alkane having one carbon, right? Can you tell me, in methane carbon atom undergo which hybridization? sp3. Yes or no? Then there are how many lone pair? 0. There is no lone pair. So sp3 0 lone pair. What is the geometry? It is tetrahedral. So therefore how it is? There is a carbon and 4 hydrogens are arranged tetrahedrally like this. So this is the tetrahedral geometry of alkane. Next, since it is a tetrahedral, what is the bond angle? So according to valency bond theory, we have studied, if the tetrahedral is the geometry, bond angle is 109 degrees 28 minutes. Next, what is the CC, carbon-carbon bond length? This is also we have studied in the beginning of organic topic. And carbon hydrogen bond length in alkane. Tell me, CC bond length 1.34, right? 54, 1.54 angstrom. 34 is alkene. Okay, then CH bond length, it is 1.110 and 1.10 angstrom or 110 picometer. Okay, so it is the structure of alkene. Next is isomerism. Alkene can exhibit which isomerism? One, structural isomerism possible. 2, stereo possible, huh? Stereo possible. Third one, conformational. Yes or no? Conformational also possible. Can you tell me, in structural isomerism we have again different type of structural isomers: chain, position, right, functional, ring chain, metamerism, tautomerism, etc. Among this, alkane can exhibit which structural isomerism? Only one, that is a chain isomerism. So here they exhibit only chain isomerism. We have studied about chain isomerism in detail in isomerism topic. Next, stereoisomerism. In stereoisomerism, there are two types of stereo. One is conformational, configurational. Okay, of course they exhibit conformational. And in configurational, which configuration they exhibit? Whether cis trans or optical. Optical. Say for cis trans, so alkene can exhibit here. They exhibit optical isomerism. Next, in conformational isomerism, they also exhibit conformation, that is also called conformational isomerism also called, tell me, E and D and L, no, the DL nomenclature, there is no other name for conformation, okay, no other name, right? DL is the configuration and RS is the configuration, so therefore they exhibit conformational isomerism also. Next, there was one previous question. To exhibit chain isomerism, alkane must have at least how many carbon atom? 4, right? One more question. To exhibit optical isomerism, alkane can have at least how many carbon atom? How many? 7. Because, for example, you see, take one carbon, it is attached to another carbon like methyl, and second carbon ethyl, here is propyl, one more is hydrogen. Right, hydrogen, methyl, ethyl, propyl. How many carbons are there? 1, 2, 3, 4, 5, 6, 7. Therefore, this is a chiral carbon. To exhibit optical isomerism, hydrocarbon, alkane must have at least minimum 7 carbon. To exhibit chain isomerism, 4 carbon. Okay, to exhibit conformational isomerism, alkane must have how many carbon? At least 2. Because conformational isomers are formed by rotation of carbon-carbon single bond. If there is only one carbon like methane, then how do you rotate? What is the meaning of conformational isomers? The isomers which are formed by rotation of carbon-carbon single bond. By rotating carbon-carbon single bond in a 360 degrees, you will get a infinite number of isomers. All infinite number of isomers are called what? Conformational isomers. Therefore, to exhibit conformational isomerism, alkane must have minimum 2 carbon. 1 carbon is not possible. Okay. So about isomerism we have studied in detail in the topic name isomerism. Okay. Next is nomenclature. So nomenclature, we have studied nomenclature of alkane in detail in the topic nomenclature of organic compounds, right? Tell me. Anyhow, let's see 1 2 example. CH3, CH, CH3, CH, CH3, CH, CH3, CH3. Tell me. To write the IUPAC name of any organic compound, the first point is select the parent chain. Parent chain must be a long chain. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So therefore, parent chain must be a long chain. Next, second rule is numbering. Numbering the long chain. You can number the long chain from left to right or right to left. So it is again based on the substituent. So here 1, 2, 3, 4, 5 will get same numbering both the side. So 2, 3, 4, trimethyl pentane. Yes or no? Next. This is the previous question. So write the IUPAC name of alkene. So identify the parent chain. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6 or 5, 6, 7. So 7 is the maximum number of carbon atoms in a parent chain. Okay. Then numbering from left to right. 1, 2, 3, 3 ethyl. 1, 2, 3, 3 methyl. And tell me. When ethyl and methyl groups are present same positions from the two ends, then give the numbering according to alphabetical order. So therefore, in alphabetical order, E come first, 1, 2, 3. Okay, 4, 5. Then you can write 3 ethyl, 5 methyl, heptane. Like that, we have written many more example. You just go through once. Okay, so there is no use. So again and again doing same topic. Okay, fine. It is a nomenclature. Next is methods of preparation of alkane. This is only important. No, one second. Before that, we'll study first physical property. No, one preparation, then physical property. Methods of preparation. Okay. Methods of preparation of alkane. Tell me. Get it. So what are the methods of preparation of alkanes? 1. From alkene and alkyne. Alkane can be prepared from alkene and alkyne. 2. From haloalkanes. 3. From carboxylic acids. 4. From alcohol. From aldehyde and ketones. 6. From acid halide, amides. 7. Hydrolysis of aluminum carbide, Al3C4, barium carbide, B2. Hydrolysis of aluminum carbide, beryllium carbide. Okay, so these are the some important methods of preparation of alkanes. Tell me, first one is from alkene and alkyne. It's very common method and simplest method also. Okay, so let us see. First one is from alkene. It is also called Sabatier-Sanderens reaction. Important. So wherever reaction has name, reaction gets name, it is called named reaction. So majority question can be expected from named reactions. Okay, so therefore here first one is from alkene. So how do you prepare alkane from alkene? Okay, from alkene this particular reaction is named as Sabatier-Sanderens reaction. Tell me, now what is the reaction? Let us take alkene is CH2 double bond CH2. Alkene reacts with hydrogen, right? Reacts with hydrogen in presence of what? Nickel, platinum or palladium catalyst. When you take nickel catalyst, it is 200 to 400 degrees Celsius should be taken in the presence of nickel catalyst. So instead of nickel catalyst, you can also use platinum or palladium also. But when platinum palladium is used, so this temperature is not required, even it takes place at room temperature also. So therefore, tell me, it is alkene converts into what? Alkane. So this particular reaction is called Sabatier-Sanderens reaction. Therefore, alkenes reacts with hydrogen in presence of nickel, platinum, palladium catalyst to form alkene. It is a Sabatier-Sanderens reaction. So here statement is not important for us, we are not studying for board level. So for us important is equation, reactant, reagent, product. If there is a catalyst, product. Okay, similarly let us take CH3, CH double bond, CH2, it is hydrogen in presence of palladium catalyst, write the product. Even you can take cycloalkene plus hydrogen in presence of platinum catalyst. Like similar to alkene, alkyne can also be taken. Alkynes reacts with hydrogen, it requires 2 moles of hydrogen in presence of nickel catalyst. Tell me. So here when you take alkyne there are 2 double bonds, 2 pi bonds, so therefore 2 moles of H2 required, it becomes what? Alkene. Okay, so this is the simplest method of preparation of alkane from alkene and alkyne. So whatever the alkene and whatever the alkene you take, you will get directly alkane. It is also called hydrogenation. Addition of hydrogen is called what? Hydrogenation of alkenes or alkynes. Okay, you can write this is a hydrogenation of alkene and alkyne. Next, second method of preparation is from haloalkanes. Right, so here second one is from haloalkane. From haloalkane again we have many methods. From haloalkane, can you tell me? So what are the different methods of preparation of alkane from haloalkane? One, very popular reaction, Wood's reaction. Yes or no? In Wood's reaction, we will prepare the alkene from where? Haloalkanes. Wood's reaction, like similar to Wood's reaction we have Wood's Fittig and Fittig reaction. They are not actually preparation of alkane but similar reactions. There is a Wood's Fittig reaction, comma Fittig reactions. Okay, so this is the reaction from our haloalkane. 2. Second one, even alkane can also be prepared from haloalkane by reduction, that is reduction of RX haloalkane. Take AB, reduction of haloalkane. C, it is reaction with iodobenzene and zinc metal. 4, from haloalkane there is another method, reduction rate, no? This is called a Frankland reaction. Reaction with Gilman reagent. Okay, so these are the 4 different methods from haloalkanes. Okay, so let us see one by one. First one is, tell me, so how do you prepare alkane from haloalkane? First one, Wood's reaction. Tell me, what is Wood's reaction? What is Wood's reaction? Haloalkanes reacts with sodium metal in presence of dry ether. It should be dry ether to form corresponding alkanes. So therefore, let us take Rx, 2 moles of sodium, another Rx, okay, then so 2 moles of haloalkane reacts with 2 moles of sodium metal in presence of dry ether, we will get a higher alkane plus 2 sodium and X, 2 NaX. Okay, then write the product. Methyl chloride plus or sodium metal. In exam they do not mention how many moles it is. We need to understand. There is a alkyl halide plus sodium metal. It should be a Wood's reaction. In Wood's reaction there should be a 2 moles. It is at 2 moles. Write the product. Bromoalkane, 2 moles of sodium, dry ether. Okay, next. Two chloropropane, 2 sodium metal, dry ether. Write the product. Tell me. So how to write product, that is important. So 2 moles of methyl chloride, it gives ethane. Okay, next, it is a 2 moles of ethyl chloride, it gives butane, 1 2 3 4, N butane. Yes or no? It is N butane. Next, now tell me, it gives what? Okay, so to write the product you do like this. This is 1 chloro, 2 chloropropane, another 2 chloropropane, right? Yes or no? Then remove these 2 chlorine. What did it become? Yes or no? Yeah, it is a 1 2 3 4, 2, 3 dimethyl butane. Understand? Okay, now let's see one note. Can you tell me, this method is not used to prepare which alkane? Which alkane cannot be prepared? Methane. Can you prepare methane by this method? If you take 1 methyl chloride, you will get ethane, right? That means methane cannot be prepared by this method. The question is like this: which of the following method is not used to prepare methane? That is Wood's reaction. Wood's reaction is not used to prepare methane. Therefore, 1, it is not used to prepare methane. 2, second one, this method is used to prepare only symmetrical alkene. Yes or no? That is even number, not symmetrical, even number. Even number alkane can be prepared. Can you prepare odd number? For example, if you take, it is a methyl chloride, you will get ethane, even number, right? If you take, it is a ethyl chloride, you will get 1 2 3 butane, 1 2 3, you will get 1 2 3 4 5 6. It means this method is used to prepare only what? Used to prepare the alkane with even number. Can you prepare odd number? For example, if I want to prepare like CH3, CH2, CH3, tell me, how do you prepare? Not. It means this method is not used to prepare hydrocarbon or alkane with odd number. Okay. But if you try to prepare, you will get mixture of alkanes. Therefore, it is used to prepare alkane with even number of carbon atoms. It is used to prepare the alkane with even number of carbon atoms. But to prepare odd number of carbon atom, then what is the condition? For example, to prepare odd number, let me take methyl chloride plus ethyl chloride in presence of sodium metal and dry ether. Tell me. So can you get now generally we expect this is a chlorine, remove the chlorine and chlorine 1, 2, 3. We expect propane, but will you get only propane? No. It means instead of propane you get propane, but along with propane some other product also formed. How? If you take 2 mole, it is now this methyl chloride itself undergoes reaction, will get what? Ethane plus this. If it is 2 mole, this 2 carbon it gives 4 carbon, right? Therefore here ethyl chloride itself undergoes reaction. Then now methyl chloride, ethyl chloride both will undergo its reaction. Then this is also possible. It means ethane, propane, butane, 3 are possible. But whenever we will get a mixture of hydrocarbons, it is very difficult to separate them. Right? The preparation of organic compound is not difficult task. The important task is the separation. But in organic, that is no, we studied in beginning only. The preparation of organic compound even prepare in our normal laboratory also. In ordinary lab also you can prepare. But when you try to prepare organic compound, in majority cases you will get the mixture of compounds, not single compound. When you get the mixture of organic compound, it is very difficult to separate them. Like because they are having similar physical property, melting point, boiling point, they are having very close properties. Due to very close properties, the separation become difficult. Now that is the here also applicable. So ethane, propane, butane, they are having approximately all properties are same. So therefore it is difficult to separate them. Okay. So therefore this method not used to prepare what? Odd number of, that is it is not used to prepare the alkane with the odd number of carbon atom. Okay. Next, one more important point. Now sometime in question they will give the product. By giving product they expect which in Wood's reaction which of the reactant is used. Okay. Question is like this. Or else you take question form only. Which of the following alkyl halides are used to prepare this organic compound? So to prepare this organic compound, which haloalkane can be used? Tell me answer. Tertiary, butyl, chloride, any halide, bromide, chloride, halide. Yes or no? See, in order to prepare this, now you should break here. Yes or no? Now see the reverse. By removing these two, will you get this or not? It means to prepare this organic compound, so these two compounds required. It means this is a meth-eth-prop-but, tertiary butyl halide. That is also same. Next, similarly, one more. Tell me, to prepare this organic compound, which alkyl halide required? You break in middle. Yes or no? Right? So remove this, you will get again this only. To prepare N-hexane, to prepare N-hexane, which alkyl halide is required in Wood's reaction? N-propyl halide. N-propyl halide required, no? So that is Wood's reaction. Tell me. Now similar to Wood's reaction, there are two more reaction: Fittig reaction, Wood's Fittig reaction. So this is take under note. It is not actually preparation of alkane, but similar reaction. So what is a Fittig reaction? Will first Fittig reaction, not fitting. ನಾನು ತಪ್ಪು ಬರ್ತಾರೆ, ನೀವೇ ಕರೆಕ್ಟ್ ಮಾಡ್ಕೊಳ್ಬೇಡಿ, ಭಾಳ ಬುದ್ಧಿವಂತರು. What is a Fittig reaction? Aryl halide, right? 2 moles of aryl halides reacts with sodium metal in presence of same dry ether, right? Dry ether, what it forms? Biphenyl. So 2 moles of aryl halides reacts with sodium metal in presence of dry ether. It form biphenyl. Do you remember where we have studied biphenyls? In optical isomerism. Biphenyls are optical isomers. They exhibit optical isomerism, but condition is what? Very good. They should be a ortho substituted, right? So ortho position must be a substituted with bulky groups, then they get non-planar, isn't it? But this is a polar, what is that? Planar molecule. Okay. Next is one more reaction is Wood's Fittig reaction. Tell me, what is Wood's Fittig reaction? Like it is a combination of Wood's reaction, Fittig reaction. In Wood's reaction we take alkyl halide, in Fittig reaction we take aryl halide. Therefore alkyl halide reacts with aryl halide, right? 1 mole alkyl halide, 1 more aryl halide in presence of sodium metal and dry ether. What do you get? Alkyl benzene. That is Wood's Fittig reaction. Okay. Next, B. B is what? Reduction. Okay. So reduction of alkyl halide. See, alkanes can also be prepared by reduction of alkyl halide. Okay. Now here important is, what are the reducing agents for reduction of alkyl halide? That's only important. Tell me, reducing agents. What are the reducing agents for reduction of this? 1. Zinc concentrated HCl. Tell me, zinc copper couple in presence of ethyl alcohol. Zinc and copper couple in the presence of ethyl alcohol, it is also reducing agent. Next, lithium aluminum hydride. Next, sodium borohydride. Okay, and even HI red phosphorus, this is one of the strongest reducing agent. Hydroiodic acid, red phosphorus also be a reducing agent. Therefore here alkyl halides undergo reduction in presence of any one of this reducing agent, it converts into alkane. So you need to identify only reducing agent. For example, let us take RX, methyl chloride. Methyl chloride reacts with zinc and concentrated HCl. So zinc and concentrated HCl which produces nascent hydrogen, and it also say first one produce nascent hydrogen, it also produce nascent hydrogen. Because of nascent hydrogen, this methyl chloride converts into methane, plus you will get HCl. It means alkyl halide converts into alkane. Okay. Therefore, if you write general equation Rx plus any one of this reducing agent, let us take lithium aluminum hydride. This is also one of the strongest reducing agent. What it forms? RH, which is called alkene. Therefore, alkyl halides converts into alkane in presence of any one of this reducing agent. Okay, see. From iodobenzene, that is, what is the name of the reaction? Frank-Land reaction. Okay, this Frank-Land reaction similar to actually Fittig reaction. It is similar to Fittig reaction. Tell me, in Fittig reaction, haloarine, right? 2 moles of haloarine reacts with sodium metal. In case of Frank-Land reaction, we take 2 moles of iodobenzene, only iodobenzene, in presence of zinc metal. So 2 moles of iodobenzene in presence of zinc metal, you just remove the zinc plus iodine and you will get biphenyl. This is actually not a method of preparation of alkane, but similar to Fittig reaction. Remember. Next is from Gilman reagent. Okay, from Gilman reagent, the name of the reaction is, it is also called Corey-House synthesis. Corey-House synthesis. In Corey-House synthesis, Gilman reagent is used. Okay, tell me now, what is a Gilman reagent? Dialkyl lithium cuprate. Dialkyl lithium cuprate is called Gilman reagent. It is R2CuLi, which is called Gilman reagent. Dialkyl lithium cuprate. So here dialkyl R2CuLi, it reacts with any alkyl halide. Tell me, what may be the product? lithium and X, lithium halide will formed. And next what is left? There is a 2R, 1R, 1R, higher alkane, and 1R, 1 copper will be there, RCU. So you will get a higher alkane. For example, let us take dimethyl lithium cuprate reacts with methyl bromide. Tell me product. Dimethyl lithium cuprate plus methyl bromide. ಏನು ಬರುತ್ತೆ? So 1 lithium plus bromine, of course lithium bromide formed, and 1 methyl group will get ethane. This is the alkane, plus 1 methyl and copper, methyl cuprate formed. Next is from carboxylic acids. So third method of preparation, right? Make it pass. Okay. So alkanes can also be prepared from carboxylic acid. See, from carboxylic acid again there are 3 different methods. One important, first one decarboxylation, very important. Decarboxylation. B, coal base electrolysis, it is also important. C, reduction of carboxylic acids. So you should remember only equations. Okay, fine. Listen. Preparation of alkane from the carboxylic acid. From carboxylic acid again there are 3 different methods. Decarboxylation. So this decarboxylation will get in almost all the topics. Important. Coal base reaction, coal base electrolysis. Not coal base reaction, it is a coal base electrolysis, and reduction of carboxylic acid. So first one, let us say decarboxylation. Can you tell me what is the meaning of decarboxylation? The process of removal of carbon dioxide, right? The process of removal of carbon dioxide from the organic compound is called decarboxylation. Then what is a decarboxylating agent? Soda lime, right? Soda lime is a decarboxylating agent. It means, so what is the reaction? Sodium salt of carboxylic acid, let us take RCOONA. It is a sodium salt of carboxylic acid. Sodium salt of carboxylic acid is heated with soda lime. What is a soda lime? The mixture of NaOH and calcium oxide. This mixture is called soda lime. Important. Okay. So therefore, sodium salt of carboxylic acid heated with soda lime, the mixture of sodium hydroxide, calcium oxide, then what is formed? Alkane. See here. Now how alkane is formed? This CO2 and this ONA. Tell me, what is the product from here? Na2, CO2 C and CO2 and O, CO3, and R and H, alkane, Na2CO3. We want this. Okay. Sodium salt of carboxylic acid undergo decarboxylation to form alkanes. But here it form alkane, but important is it form the alkane with one carbon less. Yes or no? Suppose if you take the carboxylic acid with 2 carbon, you will get what? Alkane with 1 carbon. How? For example, if you take acetic acid, sodium acetate, which is treated with soda lime, sodium hydroxide, calcium oxide, tell me what is the product. So writing product only important. Here now CH3 and this 1H, it form CH4, and remaining byproduct is sodium carbonate. Therefore here carboxylic acid with 2 carbon, no? Carboxylic acid with 2 carbon, alkane with 1 carbon. Therefore in this reaction, so alkane is always formed with 1 carbon less compared to parent carboxylic acid. Okay. Then now question is like this. To prepare the propane from the decarboxylation, which of the following carboxylic acid is used? To prepare propane, butanoic acid is used, no? So butanoic acid, 1 carbon is more, right? Then to prepare cyclohexane, which of the following carboxylic acid used? To prepare cyclohexane, we want to prepare cyclohexane, which carboxylic acid should be? Hexanoic. Is there hexanoic acid? Hexanoic acid is the cyclohexane carboxylic acid, and its sodium salt is sodium salt of cyclohexane carboxylic acid should be used, right? Like that. To prepare, take one question. Which of the following carboxylic acid is used to prepare? Which of the following carboxylic acid is used to prepare 2-methyl propane? 2-methyl propane. So what is the 2-methyl propane? On second carbon methyl group and propane. So to prepare 2-methyl propane, which carboxylic acid should be used? Tell me answer directly. So to prepare this, we need to add here 1 carboxylic group, that's it. Yes or no? So therefore it is 1, 2, 3, 4. 3-methyl butanoic acid or sodium salt of butanoic acid is used, like that. Okay. Next, and moreover this reaction is very very important for interconversions. It comes in interconversions. Okay. Next, second one, B, coal base electrolysis. Coal base electrolysis, right? See, coal base electrolysis is the method. It is actually common method to prepare alkane, alkene, alkyne. You can prepare all three. Alkane can be prepared, alkene, even alkyne can also be prepared by coal base electrolysis, but reactants are different. Then to prepare, in order to prepare alkane, so what are the reactant is used in coal base electrolysis? It is a sodium or potassium salt of carboxylic acid. Let us take sodium salt. Sodium or potassium salt of carboxylic acid undergo electrolysis. What is electrolysis? There is a water aqueous medium and electric current is passed, no? In electrochemistry we have studied what is electrolysis. Sodium or potassium salts of carboxylic acid subjected to electrolysis, it forms the alkane. Okay, now let's see how to write product first, then we'll see mechanism. In coal based electrolysis we must take 2 moles of sodium or potassium salt of carboxylic acid, and then write the product. How to write product? Then break this carbon and carboxylic group. Here there are 2 R, it converts into RR. This is a higher alkane. Next there is a 2 CO2 which form carbon dioxide, and there is a sodium plus water. Do you remember? Sodium means sodium ion. Sodium ion plus water always form sodium hydroxide plus hydrogen. No, metals reacts with water. All the metals, particularly in electrochemical series below the hydrogen, the metal which are present below hydrogen, more electropositive metal reacts with water, they form corresponding hydroxide and hydrogen gas. Okay, so these are the byproducts, but we want product is this. Okay, first of all we need to identify how to write product. That's only important. For example, if I give sodium acetate, it is subjected to electrolysis. Question will be like this only. They expect product. What is the product? So you need to remember, in electrolysis there should be a 2 moles of sodium salt of acid, and bond breaking takes place here. Then what is the product? Methane, and byproducts are there same. Okay, next one more. If it is a cyclohexane sodium salt of carboxylic acid, no, yeah, it is not benzoic acid, cyclohexane. Tell me, it is subjected to electrolysis. Sometime even water also be not mentioned. If it is electrolysis, water must be there. Tell me. We should take 2 moles, remove the CO2, sodium plus water, that is the NaOH, and of course not benzene, hydrogen gas, plus CO2 gas, NaOH plus H2 liberated. Yes sir. Okay, now question is like this. Now here also, whether this method is used to prepare alkane, methane, this method is possible to prepare methane? No, because we take 2 moles. No, even if you take 1 carbon also, you will take 2 moles here. That is not possible. So you will get ethane only directly, not methane. Next, for example, to prepare (2, 3) dimethyl butane. So which of the following carboxylic acid is used in coal based electrolysis? We want to prepare 2, 3 dimethyl butane. Which carboxylic acid should be used? Tell me. Break this. Yes or no? Take 2 moles, bond break here. No, 1 second. How? Yeah, possible? No? Possible. Okay, let's see mechanism. So what is the mechanism of coal based electrolysis? Okay, if you understand electrochemistry, electrolysis, this mechanism you can write. Tell me. Let us take here, I will take sodium salt of acetic acid, right, and tell me, in aqueous medium it undergo ionization, yes or no? Next there is a water also. Water also undergo partial ionization, gives what? H plus plus OH minus. We are doing electrolysis. When current is passed through the sodium salt of carboxylic acid, you will get ions or not? Ions, which is called ionization. And on passing the electric current, all the cation moves towards cathode, all the anion moves towards anode. Next, I want what is the reaction at anode and reaction at cathode. There are how many? There are which anions? Acetate and OH. Now, when there is acetate and OH, acetate ion discharge easily. So therefore, acetate ion, okay, and here it is negative charge, like this. It means it is 2 electrons. It undergo homolytic cleavage. So therefore, CH3, C double bond O dot plus here take 2 mole plus 2 electrons are formed. Out of 2 electron, 1 electron will come out, it forms radical. Now next, this acetate radical, this undergo, now here this bond undergo homolytic cleavage. What it forms? Methyl radical will be formed plus, tell me, now there is a one radical, here radical, it form bond or not? C radical, O radical, it form the bond, it means it form CO2. But here 2 methyl radical, we know that methyl radical plus methyl radical, they combine to form ethane. Okay, that means ethane will be formed at anode. Next, what about cathode? So reaction at cathode, which is a cation here? Na plus and H plus. Among Na plus H plus, which can discharge easily? H plus. So therefore, take 2 H plus 2 electron gives rise to what? H2. Okay. Now tell me, now what is the left here? H plus is removed and acetate also removed. What is the left? Na plus OH minus, it gives us to NaOH. So therefore, now tell me, what are the product formed here? Same or not? Now question is like this. In coal based electrolysis, which of the following product formed at anode? Which product formed at anode? 1. Alkane. Yes or no? 2. Carbon dioxide. 3. Sodium hydroxide. 4. Hydrogen. 1 and 2. Right? In coal based electrolysis, alkane will be formed at anode. And even carbon dioxide also formed at anode. Both alkane and carbon dioxide will be formed at anode, and hydrogen gas formed at cathode. Do you remember once in CET question asked, in electrolysis of all the compounds, usually hydrogen liberated at cathode. Hydrogen always liberated cathode, but in one compound it is liberated anode. Which compound? Metal hydrides. Yes, sodium hydride, magnesium hydride, or any metal hydride. In case of metal hydride, hydrogen hydride will be, that is hydrogen will be at in the form of H minus. Therefore, hydrogen gas liberated anode. But in other cases, wherever hydrogen present in the form of H plus, hydrogen gas must be liberated always cathode. Okay. So therefore, this kind of question can be expected. Now here, at cathode only hydrogen gas is liberated. Now this Na plus OH minus, it is not formed at cathode anode. Okay, after the reaction, it is a byproduct. After the reaction, so Na plus is left, OH minus left, both will combine, they form NaOH. Next, another question. In the electrolysis of sodium salt of carboxylic acid, what is the nature of the resultant solution? Acidic, basic, neutral? Basic. What is the pH of the resultant solution? Greater than 7. So this kind of question can be expected, which is linked with electrochemistry. This is mechanism, right? Next, so third one is, from carboxylic acid, alkane can also be prepared by reduction. Okay, this is already we have studied in biomolecule topic. And tell me, C is reduction of carboxylic acids. Okay, so reduction of carboxylic acids. Tell me, there is only one important reducing agent which can reduce alcohol, which can reduce carboxylic acid, which can reduce even aldehyde, ketone, acid halide, all compound into alkane. Tell me, which reducing agent? Lithium aluminum hydride is not possible for all. There is a limitation for lithium. Hi, red phosphorus. Do you remember in biomolecule where structural elucidation of glucose? Glucose reacts with Hi red phosphorus, it forms N-hexane. N-hexane. When this is possible, glucose contain alcohol, alcohol undergo reduction. Glucose contain carboxylic acid also undergo reduction. Glucose contain, no sir, not carboxylic acid, aldehyde also undergo reduction. It means aldehydes, alcohol, carboxylic acid, everything undergo reduction, it forms finally what? Alkane. So therefore, now tell me, if you want to prepare alkane from carboxylic acid by reduction, there is only one reducing agent, that is Hi red phosphorus. So therefore, here reducing agent Hi red phosphorus, carboxylic acid undergo reduction in presence of Hi red phosphorus. It is a powerful reducing agent. What it form? R will be same, COOH converts into CH3. That means the number of carbon in carboxylic acid equal to number of carbon in alkene. We will get same number. For example, acetic acid undergo reduction. Tell me, what do you get? Ethane. Right? Similarly, cyclohexane carboxylic acid on reduction, methyl cyclohexane. So remember, Hi red phosphorus not only reduces carboxylic acid, aldehyde, ketone, alcohol, acid halide, acid anhydride, for all. Now next reaction we have, that only we will write equations. Okay, it is reduction of carboxylic acid. Next, from alcohol. Okay, fourth, from alcohol. Tell me, so how do you prepare alkane from alcohol? Same reaction. Alcohols undergo reduction, ROH, in presence of Hi red phosphorus, RH. That's it. For example, methyl alcohol, write the product. Ethyl alcohol, cyclohexanol, you just write the product. Tell me here, what is the product? Methane, ethane, cyclohexane. Next, fifth method of preparation from aldehydes and ketone. See, from aldehyde ketone we have three methods. First one is same, HI red phosphorus, B, do you remember Clemmensen reduction? And another Wolff-Kishner reduction. So Clemmensen, Wolff-Kishner, both will convert aldehyde and ketone into alkene. Tell me. First one, HI red phosphorus. For example, take acetaldehyde. Okay, acetaldehyde undergo reduction in presence of hydroiodic acid and red phosphorus. What is the product? This aldehyde group convert into alkane. Yes or no? Next, Clemmensen. What is a Clemmensen reagent? Zinc amalgam and concentrated HCl. So that means aldehydes and ketones undergo reduction in presence of zinc amalgam concentrated hydrochloric acid. What they form? The same product, alkene. Next, Wolff-Kishner reduction. What is the Wolff-Kishner reagent? Hydrazine, NH2NH, right? Hydrazine in presence of NaOH. So therefore, hydrazine, NaOH. So this reagent is called Wolff-Kishner reagent. Then the product will be same. Then you may have doubt. When the same reaction, same reactant converting into same product in different reaction, what is the fun of studying all three? Right? You can study any one, no? Ella enike? Huh? Say, aldehyde ketones directly convert into alkane. This is very, very important reaction, because usually aldehyde ketone undergo reduction, they form alcohol. Alcohol undergo further reduction, they form alkane. That means to convert aldehyde and ketone into at least 2-3 steps should be required. But here in a single step you will get a product that is alkane. And in Clemmensen reagent, in Clemmensen reduction, zinc amalgam concentrate HCl is used. It means in acidic medium, this reduction takes place in acidic medium. Okay. And if you want to do in basic medium, take this reagent, NaOH. Therefore, Clemmensen reagent, which is used in acidic medium, Wolff-Kishner reagent, which is used in basic medium. Both the mediums are different. and of course this is also acidic medium. Okay, then you may then what is the difference? See, what does make difference here in these two reaction? There was question appeared previously in NEET only. Question is like this: something benzene ring given, CH OH given, and it is a CH2 given, CHO given. Okay, here something reagent is mentioned that R, the product is this. Now, what is R? Options are A, B, C, and D is all. Huh? So obviously your answer will be all, but not all. Say all can convert aldehyde ketone into alkane, all right, but you need to see other group here. What is other group in this reagent? Other than aldehyde, there is a alcohol group, right? This alcohol group is more reactive towards acid, right? Because alcohol reacts with acid, that is even HCl, HI. What happened? This alcohol is removed and you will get double bond here. We will study in alcohol topic. That means alcohols undergo dehydration. Alcohols undergo dehydration in acidic medium. Alcohol plus concentrated sulfuric acid will get alkene or not. Therefore, there is a possibility of removal of this OH group, means you will get a double bond. But in product they mentioned that there is a OH. OH is present. It means alcoholic group should not be affected. When this is not affected? In basic medium, because base do not react with this OH. This kind of question can be expected. Okay. So where R is a what? See, Wolff-Kishner reagent. So it is from carboxylic acid. Next, now aldehyde ketones. Next is sixth one, from acid, halide and amide. So it is same. Acid, halide and amide can convert into directly alkane, which is the reducing agent, HI, red phosphorus. So carboxylic acid and its all derivatives, carboxylic acid and its all derivatives undergo reduction in presence of HI, red phosphorus, will get directly alkene. So therefore, tell me, let us take RC double bond O Cl. It is reacts with HI, red phosphorus, R CS3. It means C double bond O Cl converts into CS3. Even acid amide also same. RC double bond O NH2, same reducing agent. This C double bond O NH2 amide group converts into alkene. So you need not to bother about byproduct. Even if you want to write byproduct, you can write like this. Right here Cl is there, no? Here H is there, no? There is a possibility of HCl. And here oxygen is there, H is there. There is a possibility of water. Next, here is amine is there, will get ammonia. O is there, H2O. But in organic reactions, byproducts are not important unless it has name. But in case of named reaction, balancing important, even byproduct important. But if the reaction has no name, byproduct and balancing is not important. If the reaction has name or name of reaction, everything is important. Balancing important, even byproduct also important. Okay, fine. So this is from acid halide, acid anhydride. Next is from hydrolysis of calcium, no, aluminum carbide and beryllium carbide. Okay, it is also important. Previously question appeared. Aluminum carbide, Al4C3. Aluminum carbide undergo hydrolysis reaction with water. Aluminum carbide undergo hydrolysis. Tell me. Now what are the possible products? This carbon plus hydrogen, you will get methane. How many methane? There is a possibility of 3 methane. Okay, tell me. Carbon, hydrogen, methane will be formed, and aluminium and OH will be there, no? Because H plus OH minus, right? Aluminium and OH. So there are 4 aluminium, 4 Al, OH thrice. Then tell me, how many water molecules should be taken? So 3 4s are 12. 12 means 12 H2O. Okay. So even beryllium carbide, Be2C. Beryllium carbide also undergo hydrolysis reaction with water, will get methane plus beryllium hydroxide. Is it balanced? Or 4 should be taken? 4. Okay. Now it is balanced. So these are the methods of preparation of alkanes. Tell me, once you see the heading, what are the methods of preparation? First one, quickly. From Sabatier-Sanderens reaction. So what is Sabatier-Sanderens reaction? Alkene plus hydrogen, alkane. What is the catalyst? Nickel, platinum, palladium catalyst. Second method, from alkyl halide or haloalkane. From haloalkane, again, what are the different methods? One, Woods reaction. Of course, Fittig reaction, Woods-Fittig reaction similar to Woods reaction. Next is reduction of alkyl halides. Next, reaction with iodobenzene. And what is the name of the reaction? Franklin reaction. Next, Gilman reagent. From the Gilman reagent. So what is the name of the reaction? Corey-House synthesis. Next, from carboxylic acid. From carboxylic acid has good weightage. 1, decarboxylation. 2, coal-based electrolysis. 3, reduction. Decarboxylation. What is the decarboxylating agent? Soda lime. What is the soda lime? Mixture of NaOH and CaO. Next, in decarboxylation, can you prepare the methane by decarboxylation? Yes. No, na? You can prepare, no? To prepare the methane, you can take sodium salt of acetic acid. Then remove the CO2, you will get methane. Okay. Then in decarboxylation, to prepare the hexane, which carboxylic acid should be taken? Heptanoic acid. To prepare the propane, butanoic acid. To prepare the ethane, propanoic acid. 1 carbon should be more. Okay. Next, reduction, right? Coal base. It is also important. In coal base electrolysis, see here, you'll get in alkene topic, even alkyne topic also. Remember where you get product. That means which product formed in which electrode. For example, cathode, anode. At anode, what are the product formed? Alkane, CO2. In case of alkene plus CO2 barutali. In alkyne plus CO2 barutay. Therefore, at anode, alkane plus CO2. At cathode, hydrogen gas. What is the resulting solution? Basic. Okay, fine. Next, in coal-based electrolysis, to prepare the ethane, which carboxylic acid should be taken? We want to prepare ethane. To prepare ethane, which carboxylic acid should be taken? Huh? Methanoic acid. Ethanoic acid, because that's what you should understand mechanism. CH3 COONA, no? We take 2 moles, right? Here we should remove this bond breaking here. 2 moles of methyl, it means methyl. What do you get? Ethane. To prepare butane, N-butane, which carboxylic acid should be taken? Which carboxylic acid should be taken? Huh? You break middle, and this is nothing but this, no? It means propanoic acid. If you take propanoic acid 2 moles, then you will get N-butane. To prepare N-hexane, huh? To prepare N-hexane, butanoic acid. See, you break middle and add 1 carboxylic group, that's it. Like that. Okay. To phenyl, can we prepare biphenyl? If you take benzoic acid, biphenyl can be prepared. So, because this bond will be broken and 2 phenyl rings will be added, biphenyl will be formed. Okay. So, this kind of question can be expected. And next is from reduction. Okay, reduction of carboxylic acid. So, reduction of carboxylic acid, it is in only presence of HI. Not only carboxylic acid and their derivatives. What are the derivatives of carboxylic acid? Acid halide, acid anhydride, even amides. All derivatives undergo, even amides, acid, amides, ester, even esters. All acid derivatives undergo reduction in presence of HI phosphorus, they form alkene. Okay. Next is from alcohol. Same. When carboxylic acid undergo reduction, why can't alcohol? Alcohol easily undergo reduction. HI phosphorus. Next, aldehyde ketone. Aldehyde ketone also undergo reduction, HI phosphorus. But in aldehyde ketone topic, we will study 2 more important reaction. That is Clemenson and Wolff-Kishner. See, all these reaction you don't have in our this topic. New alkene topic notes material nodidre ivella illa. Hagant extra barudde anta ankobedri. ಬೇರೆ ಟಾಪಿಕಲ್ಲಿ ಬರುತ್ತೆ. ಆಲ್ಡಿಹೈಡ್ ಕೀಟೋನಲ್ಲಿ ಇದು ಬರುತ್ತೆ. ದಟ್ಸ್ ವಾಟ್ ವಿ ಹ್ಯಾವ್ ಸ್ಟಡಿಡ್ ಹಿಯರ್, ರೈಟ್? ಇಟ್ ಇಸ್ ನಾಟ್ ಮೀನ್ ದಟ್ ಇಟ್ ಇಸ್ ಔಟ್ ಆಫ್ NCERT. ಓಕೆ, ನನಗೆ ಅಷ್ಟು ಟೈಮ್ ಇಲ್ಲ ಮಾಡೋಕ್ಕೆ ಔಟ್ ಆಫ್ NCERT. ಇಟ್ಸ್ ಎವ್ರಿಥಿಂಗ್ NCERT ಓನ್ಲಿ. ಬಟ್ in some topic we will not get these reaction here. In if you see material, hardly it is a 4-5 equations are there, not more than 4-5. But we have written nearly 10-12 equations. All these comes under one another topic related to this. So whatever the reaction related to alkane, we are studying here only. Our intention is, when we study these reactions in those topic, you need to identify. Adi bere vishaya martogtine. At least ಬರ್ದಿಂದ ನಾನು ಪ್ರಾಕ್ಟೀಸ್ ಇರುತ್ತಲ್ಲ. ಓಕೆ, ಸೊ physical properties of alkane. Physical properties. See, in physical properties of, usually in organic chemistry, the first physical property we study physical nature. In all organic topics, we will study physical nature. 2, we will study boiling point. 3, we will study melting point. 4, solubility. Stay. Only 4 physical property. If it is required, density, otherwise density also will not. So these 4 physical property we study regularly in all the topics. Okay, and moreover all organic compounds having similar property. These 4 properties are almost similar. Tell me, physical nature. So what is the physical nature of alkane? Whether they are gas or liquid or solid. So usually C1 to C4 are gases. Methane, ethane, propane, butane, till 4 carbon gases. Next, C5 to C17 are the liquids, and of course having sweet smelling liquid. Ade tinange alla sweet andre, not like pungent odor, they are having certain pleasant odor. Okay, next is C18 and above, they are solids. Solid is not like metal solids, wax like solid. So this is the physical nature. Almost all organic compounds having similar order. When comes to like alcohol, aldehyde, ketones, 1-2 carbon changes, but this is order. C1 to C4, 4 to 5 to 17, 18 and above. Okay, next is boiling point. So what about boiling point of alkanes? Tell me, whether alkanes are polar or non-polar? They are non-polar. Where is the polarity? All are carbon-carbon bonds, right? The electronegativity of all the carbons same, right? So therefore they are almost they are non-polar. So therefore they are non-polar compounds. Since they are non-polar, whether they have strong attraction forces? No. In case of non-polar molecule, they have van der Waals force of attraction. Due to van der Waals force of attraction, they have boiling points. But compared to other hydrocarbons or compared to other organic compound, the boiling point of alkane is very, very less. Therefore here first point is boiling point of alkane is very less. Very less because they are non-polar and they have weak van der Waals force of attraction. Weak van der Waals force of attractions. Okay, next point. Then what happened boiling point when the number of carbon atom increases? See, remember, the boiling point is always depends on the size of the molecule. If the size of the molecule increases, the van der Waals forces increases. When the van der Waals forces between the molecule increases, attraction increases, boiling point is increases. Therefore the boiling point of alkane increases with increasing number of carbon atom, right? Therefore boiling point is directly proportional to number of carbon atoms. As the number of carbon atom increases, boiling point is increases. Like methane, ethane, propane, butane, pentane, hexane. Which one has highest boiling point? Hexane. Okay. And it is also observed that by increasing each carbon, one carbon atom, the boiling point will be increased 20 to 30 Kelvin. So therefore, by increasing one carbon atom, the boiling point of alkane increases 20 to 30 Kelvin. For example, if the boiling point of methane is something x Kelvin, then what is the boiling point of methane x Kelvin? Ethane is, it is a x plus, it is around 20 to 30. Okay, so like that. So by increasing one carbon atom, the boiling point of alkane increases 20 to 30 Kelvin. Okay, next, there was one previous question. In case of isomeric alkane, what happened boiling point? Isomeric alkane. In case of isomeric alkane, what happened the boiling point? It is decreases with increasing branching. Yes or no? So for example, it is a n hexane 1 2 3 4 5 1 2 3 4 5 6 n hexane, no branching. Let us take one branching. Okay, it is isohexane, right? One, two, three, four, five, six. Tell me, neohexane. N-hexane, isohexane, neohexane. So which one has more boiling point? So remember, boiling point is depends on surface area or depends on its size. Now here, in case of N-hexane occupy the more surface area, right? So it occupy more surface area because of long chain. So it has more boiling point. Then next is one branching, next is two branching. Therefore, as the branching increases, boiling point is decreases. This is the common point for in all the topic. You will get haloalkane same, even you will get alcohol same, aldehyde ketone same. ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ ಮತ್ತೆ ಮತ್ತೆ ನಾನು ರಿಪೀಟ್ ಮಾಡಲ್ಲ. ಓಕೆ, ಸೊ ಬ್ರಾಂಚಿಂಗ್ ಜಾಸ್ತಿ ಆದರೆ ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಕಡಿಮೆ ಆಗುತ್ತೆ. ಸೊ ದೇರ್ ಫಾರ್ ಇನ್ ಕೇಸ್ ಆಫ್ isomeric alkane, boiling point inversely proportional to branching. Okay, next is melting point. What about melting point of alkane? See, remember, boiling point depends on size, melting point depends on crystal structure. Right, melting point is depends on crystal structure and boiling point depends on size. Then tell me, what is the melting point of alkane? So usually alkanes are non-polar, they are having low melting point. Compared to other organic compounds, alkanes having least melting point, boiling point and least solubility also. They have least melting point also. But the question is, as the number of carbon atom increases, melting point is increases, no doubt. But a hydrocarbon with even number carbon atom has more melting point with odd number of carbon atom. This point is important. Therefore, here melting point is directly proportional to melting point directly proportional to number of carbon atoms. As the number of carbon atom increases, melting point increases. Okay, but important noted point is melting point of even number carbon atoms greater than melting point of odd number carbon atoms. Okay, so what is the meaning of this? For example, melting point of 1, 2, 3, 4 butane, melting point of propane. Tell me. 1, 2, 3, 4, 4 carbon, 1, 2, 3 carbon. Obviously 4 carbon more, no? Okay, that's one case. And it is even carbon. The melting point of even carbon atom is more compared to odd carbon, because when molecule has even carbon atom, it has symmetrical structure like this, or else this can be written like this. So therefore, due to its even number of carbon atom, it is packed very closely in crystal lattice. Even number carbon atoms, alkanes are very closely packed in a crystal lattice, therefore their melting point is more. But if you take odd number, it is not symmetrically packed or very closely packed in crystal lattice. Okay, for example, if you take it is butane, propane, no propane here, butane, and here pentane. Tell me now which one has more melting point? Butane only, because due to butane its symmetrical structure, okay, it is very closely packed in crystal lattice, but not these two. Therefore here melting point of butane is more than pentane, propane also. That's what. Therefore the melting point of alkane with even number carbon atom is more than odd number of carbon atom. And if number of carbon atom increases, of course it is increases, but here exception. Here number of carbon atom more, it is less, but due to even number it is more. Okay, so it is about melting point. Next is solubility. So nothing to discuss about solubility. Why? Whether alkanes are soluble in water? No. If they are not soluble, then where is the question of less soluble, more soluble? Oh, tane. If they are little soluble, then what is the order of solubility we can decreases or increases we can discuss. Since they are insoluble, there is no question of other points. Therefore alkanes are insoluble in water. Alkanes are insoluble because they are non-polar, right? Because they are non-polar molecule, and but they are organic compounds. They are soluble in what? Organic solvent. So they are soluble in organic solvent, not water. Okay, so next is chemical properties. We'll take 5 minutes break. Chemical property doesn't take much time, hardly 40 minutes, 30 minutes to 40 minutes. Take the break, we shall continue.